Alright, this is section 2.4 from Algebra 2, writing equations of lines. So our objective is to write the equation of a line given different kinds of information. So, we're going to first start out from given a graph here. So what we want to do when we're looking for the graph is we want to figure out the easiest way to do is if we can do it is figure out two things, our y-intercept and our slope. Figure out our slope. If we can do that, we can put this into a tricky equation. I don't know why they call it this, but the slope-intercept form, by the way, that was sarcastic if you didn't tell, the slope-intercept form because we need our slope and our y-intercept with y equals mx plus b. Remember the m, that's our slope, and the b, that's our y-intercept. So let's go to the equation or some graphs and let's look and see if we can find some points. So first thing we want to do is I'm going to do the red problem first. And what we want to look at first is, do we have a good y-intercept? Well, yeah, we do. It's pretty much crossing right there. That's our y-intercept. Then we're going to find another point on there that looks like a good point. It looks like that's probably the best point down there. So to figure out our slope, all we have to do is go make a little triangle with that point, and we go up 1, 2, 3, 4. So it's a positive 4. And since we go up here 4, and then from that point we go left 3, it's going to be negative 3. So again, our slope, m equals, and we do rise over run. Well, we're rising a positive 4, and we're running, going to the left, a negative 3. So really, our slope is negative 4/3. Now again, we got to find our y-intercept. Go up 1, 2, 3, 4. So our y-intercept is 4. So all we have to do now is plug this into our equation. Y equals mx plus b. So y equals m, that's our slope, negative 4/3, x plus our y-intercept of 4. There's our first equation, y equals mx plus b. And by y equals mx plus b, I did mean y equals negative 4/3 x plus 4. Now I'm going to do my second line. I'm going to do that blue line. So again, we're going to look for a good y-intercept, and there's a good one right there. And we can look right there. Our y-intercept is up 3. So y-intercept equals, and really the way we would write this is 0, 3. So our y-intercept is equal to 3, right? Now we got to find a second point on there, find a good second point. And this one looks pretty good. And I'm going to make a triangle with it. Now you can go up like that, or you can go down. It doesn't really matter which way you go. You'll end up with the same slope. And I'll show you in a second here that that's true. So let's start here. We're going to go right 3, so that's positive 3. Then we're going to go up 2, so that's positive 2. If I go the other way, I'm going to go up 2, and I'm going to go right 3. You can see I did the same things, I just did it in two different orders. So again, remember our slope equals rise over our run, rise up or down, so that's 2 over our run, which is 3. You can see we don't need to simplify that because it's already simplified. So now what we have to do is plug it into our equation, y equals mx plus b. So y equals m 2/3 x plus b, well our b equals 3, so just 3. There's our second equation, y equals 2/3 x plus 3. Now for our last equation, again we're going to look for our good y-intercept, and you can look right there. Our good y-intercept on this is y-intercept is at 0, 0. So that means our b is going to equal 0. Well, that's easy. Now we're going to go and find our next good point. If we look on here, another good point is probably right about there. So now again, we can go on the top or the bottom. I'm going to go to the right, I think. I'm going to go up 1, 2, 3, so that's plus 3. Then you go left 2, so negative 2 to the left. And again, remember our slope, m equals rise over run. So m equals positive 3 over negative 2. So simplify that, m equals negative 3 halves. So when we write this into our equation, y equals negative 3 halves x plus 0. Well, I can simplify that more. I don't need to write the 0. So simply y equals negative 3 halves x. So that's how you do it when you're given graphs. You find the points that work and the slope, and you're good to go. Now, what if I give you the slope and the y-intercept? Well, we already kind of talked about this. Remember, slope and y-intercept. Slope-intercept form, y equals mx plus b. Remember, m is our slope and b is our y-intercept. Well, we should be able to do these easy peasy. Now, I'm not going to graph these problems. I suggest you do just to get an extra little practice on doing the graphs, but I'm not going to graph them just because I want to keep this video just talking about writing the equations. So, find the equation of a line with a slope -2/3 and y-intercept of 5. So again, slope-intercept, that form is mx plus b. All we have to do is plug in our pieces. Our slope is our m, and our y-intercept is our b. So, y equals -2/3 x plus 5. There's our slope-intercept form. There's our equation. Now again, I suggest graphing this equation just to get extra practice. The next one we're going to talk about is if we're given a point and a slope. Now this form is something you probably haven't seen very often. I know you did see it in Algebra 1, high school algebra. It's a point-slope form. Now again, the name, so tricky how they came up with these names. It means nothing compared to what you actually have to graph. Oh wait, that's right. You're finding the point, or you're given a point and a slope in order to graph this. Well, the point-slope form is y minus y1 equals my slope m times x minus x1. Now what that y1 and x1 are, those are the placeholders for actual values, actual numbers that are going in from a point on that line. So that's the point is my y1 and my x1, and my slope is the m. So let's do a problem. Again, I'm not going to graph any of these. I expect you guys to do it just so you get extra practice. So find the equation of a line that passes through the point 4, -1 and has a slope of -2. Again, slope or point slope form. Y minus y1 equals my m times x minus x1. Something that might help you guys is to actually label these points. This is my x1, y1. So I actually can plug those in now. So my y minus -1 is going to equal -1/2 times my x minus 4. Now I can do some simplifying. I can get rid of some parentheses up here. And I can do, okay, well this really becomes y plus 1 equals -1/2 x. And negative times a negative is a positive. 1/2 times 4 is 2. Now really what we want to end up in, we want to end up in the slope-intercept form. So I want to make it y equals mx plus b. I needed to make it look like that. So I'm going to move the 1 over. Really this can become y equals -1/2 x plus 1 because I subtracted 1 from both sides. And there's our final equation. We started out in point-slope form. We ended up in slope-intercept form. Let's do another example here. So again, I'm going to label it. So find the equation of the line that passes through -2/6 and has a slope of -3/2. So I'm going to label my x1, y1, and then we're going to go and we're going to look at the equation. Y minus y1 equals my slope times x minus x1. Now let's fill in the pieces that we have. Okay, well we have y minus y1 equals my slope times x minus -2. Now I'm going to go and get rid of some parentheses, distribute some things, change things up a little bit. First thing I'm going to do though is I'm going to simplify that right one. So y minus 6 equals -3/2 times x, sorry, a little difficulty, times x plus 2. I'm just going to make things a little bit easier going on here. So now, when we keep going, can simplify this a little bit more. Y minus 6 equals -3/2 x. Now positive 2 times -3/2 is really going to end up being -6/2. Well, 6/2, that's really the same thing as 3. Last step I'm going to do is I'm going to add 6 to both sides. So we get y equals -3/2 x. Now I'm adding 6 to both sides to get rid of the -6 over there. So I'm going to end up with plus 3. Now one more time, I suggest you guys graph this just so you get some extra work on graphing. Alright, next thing we're going to do is given 2 points, how do I graph it? Well, from this, you guys are going to have to find the slope. And you should know how to do that using the slope formula. And I'll write that up here. Remember that m equals y2 minus y1 over x2 minus x1. And then from there, you're going to put a point and the slope into the point slope, not the slope intercept, the point slope form. And last thing, if you want to make sure you put that list is, or make it into, change into slope intercept form. So I'm going to do some examples here for you so you guys can see what it is. I know that might have been a little tough to understand, so let's do some examples. So again, first thing, find our slope. M equals, so we need to make x1, y1, x2, y2. So m equals 15 minus 20 over negative 6 minus negative 8. Well, 15 minus 20 is negative 5 over negative 6 minus negative 8. That's really like negative 6 plus 8, so negative 5 halves. So there's our slope. Now we need to plug it into our point slope form. And I know what you guys are asking is, well, which one should I do? Should I do this problem or this point, or should I do this point? Well, I'm going to show you real quickly that it doesn't really matter. So I'm going to first plug in my negative 820 into this. So we have, remember, our point slope form is y minus y1 equals m times x minus x1. So I'm going to plug in negative 820 here. So we get y minus 20 equals negative 5 halves times x plus 5 halves, because it's minus 5 halves, and I'm going to make it opposite. Sorry, not minus 5 halves. Minus 8 plus 8. All right, now we multiply through, so y minus 20 equals negative 5 halves x. Now positive times a negative is going to be a negative. 8 times 5 is 40, divided by 2 is 20. Now I'm going to add 20 to both sides to get rid of the 20 on the y side. So y equals, well, if I do negative 20 plus negative 20, I'm just going to end up with y equals negative 5 halves. Now quickly, I'm going to show you that same thing with the green points here, negative 6, 15. So y minus 15 equals negative 5 halves times x minus 6. Sorry, plus 6, because it's minus negative 6. Now we end up with y minus 15 equals negative 5 halves x. 6 times, and it's going to be positive times a negative. 6 times 5 is 30. Half of 30 is 15. You guys can probably already see it. We're going to add 15 to both sides, so we get y equals negative 5 halves x. Now the reason I did both of them is I want to show you that it doesn't matter which point you pick. If you found the right slope, you're going to end up with the right equation no matter how you guys plug it in. If you do this right steps and you do it correctly, you'll end up with the same thing. So pick whichever point you want. I'm going to let you guys try this one on your own. I'm going to put the answer up in 1 second. All right, here are 3 examples to try quickly, and then I'll put up the answers in 1 second. All right, here are the answers. Check your work. Let me know if you have any questions. Positive I'm going too fast for that. All right, next thing we're going to do is we're going to go back and remember parallel and perpendicular lines. Remember, parallel lines, they have the same slope. Same slope. Perpendicular lines, have opposite reciprocal slopes. Opposite reciprocal slopes. So let's look at some examples here. So find the equation of a line that passes through negative 4, 2 and has a slope perpendicular to negative 1/2. So remember, perpendicular, that means it's the opposite reciprocal. That means it's, instead of being negative, it's going to be a positive. And the reciprocal means we take this and we flip the top and the bottom. So it's going to be positive 2 over 1, which is the same thing as 2. There's our slope. Easy peasy, right? Now to find the actual equation, we have to plug this into our point slope form because we have the point here, so let's plug it in. Y minus 2 equals 2 times x. Instead of minus 4, it's going to be plus 4 because it's minus negative 4. So y minus 2 equals 2x plus 8. Now y equals 2x plus 10 would be our equation. I know I've said it before, but I'm going to expect that you guys graph this so you get some extra work doing it. All right. Find the equation of the line that passes through negative 2, 1 and is parallel to the equation y equals 3x plus 1. Well, if it's parallel, what do we know? We know its slope is the same. So we know m equals negative 3. So now again, we can just plug this into our point slope formula because we have our point and we have our slope. So y minus 1 equals negative 3 times x plus 2. Y minus 1 equals negative 3x minus 6. Add 1 to each side, so y equals negative 3x minus 5. All right. These problems are going to get you a little bit more tricky because you actually have to do a little bit more work. So let's look at the equation of the line that passes through 6.63 and is parallel to 3x minus 4y equals 8. Well, first thing we need to do, we need to figure out the slope for this. That's in standard form. So I'm going to do is I'm going to take this and I'm going to convert it to slope-intercept form. So 3x minus 4y equals 8. What we need to do is we need to get the y by itself. First thing I'm going to do is I'm going to subtract 3x. And I like to put my x's in front. So negative 4y equals negative 3x plus 8. Divide each piece by negative 4 to get that x or that y by itself. So we end up with those cancel out. Y equals negative divided by negative is positive. 3/4 x. And then positive divided by negative is negative minus 2. Really all we cared about in that problem was right here, my slope of the equation. So we know my new slope of my equation is still going to be 3/4 because it's parallel and it's got to be the same. We also know the point is 6, 3. So y minus 3 equals 3/4 times x minus 6. Go from there. So y minus 3 equals 3/4 x minus positive times a negative is a negative. 6 times 3 is 18/4. So 18/4, which is the same thing as 9/2. Now we need to add 3, so we need to think about that in halves. How many halves is 3? It's 6/2. So y equals 3/4 x, and if I have negative 9/2 and I add 6/2, we're going to still be negative 3/2. There's our equation. All right, this last problem is almost identical to this first problem up there, but it's perpendicular to that point. So it's going to change things up a little bit. We need to be perpendicular to negative 3x, so that means it's got to be the opposite reciprocal, which means it's a positive. And instead of 3, we're going to take that 3 over 1 and flip-flop it, so it's 1/3, positive 1/3. All right, and our point is up there, so let's plug it in. So y minus 1 equals 1/3 times x plus 2. Y minus 1 equals 1/3 x plus 2/3. Now we're going to add 1, which is the same thing as adding 3/3 to both sides. So y equals 1/3 x. 2/3 plus 3/3 is 5/3. Sorry for the long video. We only have 2 more problems and then we're going to be done. So find the equation of a line that passes through 3, negative 5 and is parallel to y equals 1. Well, what's the slope of y equals 1? Well, rise over run, right? So we're going up and down. Remember, we talked about this. Y equals 1. When we have y equals, we know that that is a horizontal line. And when it's a horizontal line, we know that it has a slope of 0. All right, so our slope is 0 on this one, so we can go and we can plug it in. So we know it's parallel and it passes through the point here. So let's plug in our points here. M equals 0. So y plus 5 equals 0 times x minus 3. So now we go ahead and solve this. So we have y plus 5 equals, 0 minus 0. So it equals 0, right? So we'll just cancel. Okay, let's go there. Equals 0. Now I need to subtract 5 on both sides. And we get y equals negative 5. Now I'm going to show you guys might even see it. There's a little trick here. If it's y equals and it's parallel, that means it's the same. Well, look at this. That's the same thing, isn't it? If it's y equals a number, we know it's going to be parallel to it. Just got to look at the y number in it. All right, let's try a different one, a little bit trickier than that one. Find the equation of the line that passes through 3, -5 and is perpendicular to y equals 1. Again, this one is horizontal. Well, what kind of line is perpendicular to a horizontal line? Well, that's a vertical line. And that is perpendicular, right? Well, vertical lines, they have no slope. So how can I plug that into the equation? I can't do y minus or plus 5 equals no slope times x minus 3. I can't do that. That's impossible. I can't do that. So all we have to do, well, think about it. If we looked at up here, we looked at where it was or parallel to it, we looked at the y. When we're looking down here for one that's perpendicular, all we need to do is look at the x. And so when it's perpendicular, it's not going to be y equals anymore. It's going to be x equals, because it's got to be vertical. And all we have to do is look at that x value, x equals 3. All right, that's all we're going to do for notes in section 2.4. Sorry for the longer video here. Let me know if you guys have any questions.